Okay, this is question 4 on Homework U12. It's about a particle p with constant acceleration 2I minus 3j. At time t seconds, its velocity is v meters per second, and then we've got this initial condition when t equals 0. We've got this initial velocity over here, minus 2I plus 7j. So the question is asking us to find the value of t when p is moving parallel to the vector I, find the speed of p when t equals 3, and find the angle between vector j and the direction of motion when the direction of motion of p when t is equal to 3. Okay, so let's have a look at the first bit. Find the value of t when p is moving parallel to vector I. So first thing we need to do is we need to get an expression for the velocity vector. So we can say in part A, we know that the velocity is equal to the initial velocity plus acceleration times time. So this is our initial velocity, and then this is basically the change in velocity. So the velocity any time t is the initial velocity plus the change in time. Now we know from the question that our initial velocity u is minus 2I plus 7j. We know from the question that the acceleration is 2I minus 3j times t. Okay, and then simply all we've got to do now is expand this bracket out and then bring all the i's together and bring all the j's together. So I've got minus 2 plus 2t times I plus 7 minus 3t times j. So 2t is that 2t minus 3t is this 3t here, and then we just factorize out the I and the j. So we've now got our expression for the velocity vector at time t. Okay, now the question asks us to find the time t when we're moving parallel to the vector I. So if we're moving parallel to the vector I, that means that the j component must be equal to 0. So when parallel to I, there must be no j component. Then j is equal to 0, which means that 7 minus 3t equals 0, which means that t equals 7 divided by 3, which is 2 1/3. We just leave it as that. Okay, part B was to find the speed of p when t equals 3. So at t equals 3, all we do now is substitute 3 into this expression up here to find the velocity. So the velocity vector is minus 2 plus 2 times 3 times I plus 7 minus 3 times 3 times j. And 2 times 3 is 6, minus 2 is 4, so we get 4I here. 3 times 3 is 9, minus 9 plus 7 gets me minus 2j down here. Now, go be careful here because the question asks us for the speed, okay, not the velocity. Speed is a scalar. We're not bothered about which direction something's going if we're just looking at the speed. So the speed is basically the magnitude of this velocity vector here. This is a vector. So the speed is going to be 4 squared plus minus 2 squared, and then the square root of all of that, which is 16 plus 4, and that gets me a speed of 4.47 meters second to the minus 1. Okay, next bit is find the angle between vector j and the direction of motion of p when t is equal to 3. So when t is equal to 3, we're going to substitute the 3 into this equation that we've already got at the top here for the velocity vector. So at t equals 3, it means that the velocity vector is going to be minus 2 plus 2 times 3 times I plus 7 minus 3 times 3 times j. Okay, so we've got, again, we've got the same as before, 4i minus 2j, and we're trying to find the angle with vector j. So you can imagine a diagram looking something like this. There's vector j, and we've got a velocity vector which is going to be 4i going this way, minus 2 coming down here. So we've got 4i minus 2 and we're looking for this angle down here. So there's a 4 and there's a minus 2. So we find that angle there, theta, when we add that to 90 degrees to get the angle with j. So again, basic trigonometry now. This is, we say that the tan theta is the opposite divided by the adjacent. So that's magnitude 2. 2 divided by the adjacent, which is 4. 2 divided by 4 is a half, which means that theta is tan to the minus 1 of 0.5. And that gets me 26.5 degrees. So the angle with vector j is going to be 90 plus 26.5, which is 116.6 degrees. Okay.